So let's go ahead and dive on in. We're going to look at the foundations first. Websites are made of code. Code is written in languages, and there's 3 languages that are the foundations of websites. We have HTML, which makes our basic content, CSS, which is how it's designed, how it looks, the layout, the visual effects, the design to it, and of course JavaScript, which is the web versioning of programming code. JavaScript executes in the browser. So rather than having this run in a separate machine and be sent over within a browser, it'll go ahead, load, parse, compile, and execute for a user. And about 97% of sites use this. So oftentimes we think of rendering issues as being relegated to those using JavaScript frameworks like Vue or React, but actually it affects anybody who has a reliance on their primary content to use JavaScript. It's a powerful tool. We can transform just a couple of lines of code into a full site. It's very impressive. And similarly, Googlebot is code. Googlebot obeys rules, and it runs in a set order. So why is it then that so many of our optimization efforts fall into the gap? This is not uncommon to have a pretty decent, especially when you get to a large-scale site, gap between the number of pages that we submit and then we index. This is a reference to some work that Tomek Rudzki did, I believe 2018, but he did a study on index coverage of JavaScript content for a number of sites and found that a lot of them had quite a bit lacking. So what is causing this issue? Well, fundamentally, it's our rendering. So rendering is the process between our initial HTML response, that is what is given to the requesting server by your server, the process of building the frames out, and then creating the DOM. Now, Googlebot actually flattens the DOM. This is being very important to us because that space between initial and how it builds out throughout the consecutive frames to final can vary. Let's look at the mechanics of rendering. First off, Googlebot is simply a user agent. All it refers to is the name of the requester, and this is information you would find in your server logs. It's common across every requesting, every requester device. It's a little bit of a pen pal accountability diary. And it's one of the many microservices that Google uses in search. You've got to think about it. This is a massive company that has many tools, and they use a lot of them between both organic search, paid search, browsers, tools, functionalities. If you've built it once and it's successful, and you're trying to make something at scale, it simply only makes sense to continue using this. Google uses Chromium as its web rendering service, and that's the same Chromium that you all know and love. It's probably in your browser right now. And that's great because it means it's really not as hard to find out the nitty-gritty details about rendering as we would be a little bit concerned with. I'm sure we're all big believers that Google is fully transparent all the time. But good news, Chromium is open source, as are some of the components it's built of. So Blink V8, 2 of the critical pieces beneath it, also open source. When it comes to the very mechanics of how it has to work, you can find out. There's documentation. And better yet, you can find out now because I'm actually going to go along with this process for you. This is a great quote from one of the Google engineers at the Webmasters 2019 conference. When we crawl your page, we fetch the content and we give it to Google. Then Google runs all the scripts. It loads additional content. Once everything's loaded, we take a snapshot of the page, and that's actually what gets indexed. Fantastic. All right. We're ready for this? We're going to follow along. First up, a URL gets pulled from the crawl queue. There are 160 trillion was the last number I could find, but that was so far out of date that I'm not sure it's entirely accurate. It's a big queue back there. So Google's going to grab one of these. It's going to make a request using the Googlebot user agent. Its next step up is going to be to read the response headers. These are important. These are knock, knock, who's there? This is the who's there before we get to a punchline. And the response headers answer two important things. Does the thing I asked for exist? And is there anything I should know about this before I continue looking? And sometimes this can include a canonical directive or an xrobots tag that gives direct index directives. Both very important things, particularly to troubleshoot your rendering problems. It will get that initial HTML and it'll parse it out. And Google creates with this what's known as the crawl DOM. You can view the crawl DOM with that right-click view source in the initial HTML. After that, it's going to go ahead and pass that content to the index processor. The index processor is our friend. It's going to go through and read this newly acquired content and find all of the links and resources listed in the page, adding them back into the crawl queue. The index processor will then pass valuable content to the index. So if your initial HTML is able to answer a user's intent, your page may enter the index earlier than having to wait for a full render. Next, once all those resources are queued up, we're going to queue the page for rendering. When the resources are available, which is pretty fast these days. I know in 2018, Google was like, hey, we've got some serious problems with how we index our content. But if you'll notice since then, they've also moved to a mobile first index. They've also done a number of things that go, hey, we want the smallest version, with the idea that you're going to execute less JavaScript, less third-party scripts, less bells and whistles on the mobile site from the desktop, which makes it more feasible for them to be able to crawl these things in a rapid succession. We've got to remember that as important as it is for us to design for the small screen first, to be good citizens of the web and good creators, understanding that we frequently have great privilege in the connectivity of our devices and the bandwidth they can support, the functionalities that they have. Not everyone has that. Fundamentally, when we make a case for why our site needs to be lean, fast, and mobile first, it is because Google doesn't want to deal with the tech debt. It's a lot of money to store all the content, get all the resources for any version of a site. So doing it from the mobile version, which should equally answer users' intent, simply makes sense. Google's web rendering service crawls the page. Google's web rendering service uses the crawl DOM and the resources to assemble that page they've made. And the renderer processes the renderer HTML to that index processor. So this is not really our second wave of indexing, but initially it's what we refer to it as. Remember that here that Google's going to flatten the DOM as it goes, so it's going to overwrite things. If you only put it in the initial HTML and not the rendered HTML, it's gone. Google flattens over it. It's not going to see it. The processor extracts links from the rendered DOM, places them back into the queue, and it takes that valuable content and passes it to the index. So congratulations, now you've made it to the land of ranking of all the other factors we have involved. It's a complex process, but it's the same for everyone. And knowing a little bit about it can be pretty beneficial for us. So knowing this is a technical process, it is steps 1, 2, 3, 4, 5, and so on. We can also know that how our page is rendered matters. We have different options. Let's look at some of them, okay? They all start the same. A request is made to your site. Knock, knock, who's there? When we have client-side render, we essentially send back this very shallow version of a content. Minimal there. Doesn't really tell me a lot. This little demo version I have, you can see there's a head and there's a body in terms about What this page has information on, you have no idea. And if you as a human have no idea, nor does Googlebot. We also can have a server-side render. That means we pass back fully parsed, rendered HTML to them. We can do something called pre-rendering. It's important to know our words here. I found one of the biggest challenges in SEO throughout the years has been just simply confirming that the words I use mean the same thing to someone else. And pre-render here refers to you made it at build time. When you compile that fresh version of the code, you output some rendered HTML and you have it ready to go. Dynamic rendering is a overly complex and formally recommended process in which you would have two versions of your code. The first would be a fully parsed HTML available to Googlebot, and the second would be that more shallow app shell or client-side render that you would give to a normal human. It involves having an observer in the middle that can differentiate bot from person. Pretty complicated there, if we're honest. We can also do isomorphic rendering. Isomorphic, trisomorphic, progressive rehydration. There's a lot of names for this particular one. But it basically boils down to load what matters when it matters. This is a built-in capacity for Angular, React, a bunch of the new JavaScript frameworks. You could use intersection observers to go ahead and do this. It's friendly, it's cool. Chances are your framework has it built in. Take a peek at it. We have all of these options, and it's important to just note some of them are better than others. So you can't control Googlebot's process. That's simply not feasible, but you can control how you present your content to them. So we're going to look at those rendering options and talk about what works well or maybe not so well. So client-side render is simple, easy. Here's the thing though. We are giving anyone requesting our content a pile of building blocks, and then we give them oftentimes unreasonable expectations about what to build with it. It causes some problems. Each script has a probability to fail. So if we have our simple page here and it uses 4 scripts, and each one of those scripts is responsible for creating specific content on our page, okay, well, probability to fail. What happens when they fail? Things start getting taken out. What happens if that initial call for jQuery fails? Then it's all taken out. We can see just with 2 of those 4 scripts failing, it's a big difference in the content that we have available to Google and to users. Users' browser is probably going to retry it a couple more times. If you are looking for a product to buy and the script that lets you push the buy button on your site failed to work, you're not going to buy. Simple. It's important to know with the client side, on many of these actually, performance matters. Again, this isn't altruism. This is simple tech debt. Google will interrupt CPU consumption. It will interrupt script. And if you have excessive CPU consumption, it's going to negatively impact your index coverage. Speed is not the same as performance. We convolute these two quite a bit. Speed is the idea of you're running a race and there's a start and a finish line. Performance is not the same. Your page is a little bit like building a bookshelf. It's not how quickly you built a bookshelf. It's how stable was the result. How useful was the result. Next, we can look at our server-side rendering. Server-side was recommended for a number of people who just, this way we're sure all of our content is available to Google. Unfortunately, we all have to wait. We can only see the content that's available in our viewport as we first start, but we all have to wait for the rest of this content to get there. And if we are rendering the full page, every gadget and gizmo down through the footer, the user has to wait for this. You've got to remember that hovering thumb on a back button is not lenient. It will go ahead and decide to use another site, to go back to SERP and find something else. Pre-render. Again, another solution that picked up a lot of momentum. People found to be an potentially viable, very interesting intermediary as we figured out rendering as a whole. There are services that do this. Here's the thing though. You update that corporate credit card, but you forgot to update your pre-rendering service, you will see something like our friends at Airbnb did. Your third-party rendering tool has you quite compelled to make sure they always have their money. If something were to go wrong, it would be a very harsh impact, probably not your best friend. You can, of course, pre-render and have those copies available locally, but this is tech debt. This is more servers dedicated, more storage dedicated. You've got to consider the scale of replicating across CDN networks, whatever your site may have. There's some unspoken debts that come with this one. Next up, dynamic rendering. The sheer complexity of this should give you an idea of the sheer complexity we're talking about. Ideally, one equals the other. The version we give bots is relatively the same content that we are giving our users. Are you sure about that? Because what we ultimately have is 2 times the server costs, 2 times the test cases in QA, and we have half the visibility into what is actually happening on our site. Are you sure those two behave the same? Are you sure one's not broken in a way that no one really knew? Because dependencies are never mapped. No. Large sites, enterprise sites, it's a little bit like remodeling a house, and you put in a new kitchen sink, but for some reason 2 months later the bathtub's on fire. That's the nature of the beast. This makes it harder for you to see and diagnose issues going on. So which is best? I am not qualified to tell you that. No one who does not thoroughly and explicitly understand your stack, understand the databases you use, the front end you use, the back end you use, all of these pieces together, they are not qualified to come in and tell you which is best for you. Because this is ultimately about what gives you the best lift for the investment. Investment's not just money. Investment is time to the project being completed. Is the project going to be completed? I've seen many of these projects where people try and revamp their rendering approach, never make it to production, never become a fully viable project. There's development hours, there's cost of technologies, there's employee burnout, the cost of your childhood memories. Is it worth it? So look out for the lowest lift. What is the biggest investment you can get? All right, well then how do we make it better? We're going to follow a process. This is the same process regardless of which strategy we use, of really anything else. We need to have visibility, diagnostics, and iteration. If it's not as though our website's a car. With a car, you could take it into the shop and be like, any new brakes, and they can be like, yeah, it's going to cost you this much money. Each one of these is like a car that we custom built ourselves. Even if you're using an off-the-shelf framework, there are features, backends, all sorts of things in there that are bespoke to your site. So we need to be able to see what's happening, measure what's happening, and improve it. We're going to start by just simply using meaningful status codes. These are useful. Your server logs give you better detailed information before anything in Google Search Console will. These are incredibly useful. Give every asset a unique address. If you have a single page application, update that URI using the history push state. Track your analytics. If you've got not fully reloading page views, like with a single page application, using virtual page views. A little simple code snippet here to give you an idea of what that is. And we want to prioritize our users above any marketing pixel, above anything else, just lazy load. And this is simple. We can just add async or defer attributes. And loading equal lazy is natively supported by Chrome. So here's the great thing. Anytime that you hear, well, it's supported by Chrome, but not across the world, not across all browsers. Google uses Chromium. You're good. If Chrome supports it, Googlebot will support it as well. And when we see async and defer and lazy, if they're not acknowledged by like IE, it's going to be ignored. It doesn't do anything else. You're okay. We want to make sure our content's discoverable. If you have accordions, tap to load more, anything like that, toggle your CSS visibility and make sure your links are crawlable. Crawlable links require both an A and an href value to them. If you have a span href, if you have an on-click href, none of those are going to be discoverable. We want to use clean, consistent signals throughout. Googlebot is not going to see past an xrobots no index response from the server to see that you wrote in an index meta robots tag on the rendered DOM. If it breaks in that step of the process, it does not go any further. Use consistent information for your title tags, for your descriptions. If you overwrite that, again, Google flattens the DOM. So every time they execute that script, they're not going to keep the separate layers. If you can think of like a photo manipulation file, a PNG, a TIF, Adobe file, you've got those layers you can individually move and manipulate. Those are very expensive to keep stored and to understand. So every time Google goes ahead and adds a new layer in writing your DOM, they flatten this back down. It's important to know. And most importantly, protect your head. Protect the head of your page. If you have a synchronous third-party script, if you have an iframe, if you have a NoScript tag in your head, HTML5 protocol calls for the head to close once it encounters that closing head signal. If a third-party script takes too long, it will close the head. And that means that all of the very important information in your head tag is lost if it's below where it failed and closed. You may see this by a lack of detection for ahref tags, your canonical information being in there. If it's below that and it prematurely closed, it was never discovered. So this concludes what I have for you folks. Thank you so much for joining me here today. I appreciate you greatly. Yes. Thank you so much.